A Lamella separator is a highly efficient particle separator usually used in water treatment plants. In this video, we'll describe how a Lamella separator utilizes the power of gravity, why the design and kinetics of the system must be engineered correctly, where Lamella separators are efficient and effective, and what Lamella separators are actually used for. Lamella separators work efficiently due to two different factors. The first, a larger available settling area, allows for more efficient use of facility space. The area that is fully available in a Lamella separator is about 90% of the surface area of the plates. Compared to a conventional settler, this permits more efficient space management. The second is the path of the falling particle. As the flow of the clarified water moves upward towards the drain, the particles will slow down due to the pull of gravity on the higher density particle. The particles will then fall slowly out of the water and land on the plates. Since the plates are only an inch or two apart, this leaves a much smaller settling distance for the particle compared to the height of the basin. The combination of a smaller falling distance and the easy collection of particles decreases the time needed for separation. As the slurry moves up the plates, clarified water is pushed out of the basin, while the particles slowly separate out of the water and slide down the plates. In a Lamella separator, the plates take up about 1/4 of the basin volume. Particles enter the basin furthest away from the lamella plates. Coagulant particles and water are evenly mixed while entering the basin. Once in the basin, the particles follow a course as illustrated, some being recycled back while others are pushed up through the plates. The design of this separator was based on industrial-sized operations. Plywood and plexiglass were used to build the basin, with the plates made of metal sheets. All the seams were sealed with white silicone glue to ensure a waterproof container. Calculations were made to optimize a retention time within the basin that allows for proper flocculation. The lab-scale basin has a volume of 48.1 liters and a feed rate of 4.74 liters per minute. The inlet flow is coming from a flocculation basin where there is a constant concentration of particles, flocculants, and water. The plates are placed at a 60-degree angle to ensure the particles will slide down the plates after settling. The clarified water exits the basin near the top of the plates. Flocculation is a process in which particles of opposite charges attract each other to form larger particles. A flocculant is introduced into a slurry and the particles arrange around the ion in solution. In the flocculation basin, this process begins, but many flocks are broken up in transportation between the flocculation basin and separation basin. Although initially used for water and wastewater treatment, other industries have implemented the technology as well. A freestanding Lamella separator can be used in a variety of applications, including smaller water treatment plants, process water treatment, pulp and water production plants, and food industry applications. Plate separators first came to the U.S. in 1977, where they became popular for application in municipal water and wastewater treatment industries. Before coming to the U.S., Lamella plate separation units had been successfully utilized in Europe since the 1960s. Today, inclined plate settling devices are an essential unit operation of almost all surface water and wastewater treatment plants for high-rate sedimentation purposes. Because the driving force behind the separation is gravity, no power costs are required, making the process economically feasible. However, the system is limited because only particles large and heavy enough to settle naturally by gravity will be removed. Flocculation and coagulation typically come before sedimentation to increase particle diameter and improve settling. Lamella separators utilize these processes to clarify and separate particles in water.